This is problem number 11 on page 282. Y double prime plus 3y prime plus 2y equals to 12e to the x. I feel like I've probably done this one before. Looks kind of familiar, but who knows. We may have done it different ways earlier. Now this one, if you have this book, bottom of page 275 gives a great technique. It says that what happens when q to the x, the right hand side, is equal to constant b times e to the ax. So here b would equal to 12 and a would equal to 1x. Alright, it says that then the y particular, which if you write it as 1 over polynomial operator times b e to the ax, this is equal to b e to the ax over polynomial on a, as long as that's not equal to 0. Okay. I suspect this situation where it does equal to 0 would crop up when the root of the characteristic equation is the coefficient of the x up there. In other words, if one of the roots was 1, then I think p of a would be 0. Alright, well, we don't have to worry about it for this problem. Now, this problem and the next few we'll do are related to an exponential shift theorem for inverse operators. So we looked at an exponential shift theorem for operators, and we have one for inverse operators. So the author goes through and actually proves this in the book, and I think I'll just go ahead and use it as is. And so let's, looking at this problem here, we have d squared plus 3d plus 2 operates on y equals to 12e to the x. So y particular would be 1 over d squared plus 3d plus 2 operating on 12e to the x. Oh, another telephone call. Well, we'll try that again. That was my wife. That's about the time of day I get phone calls. So where was I? We were down here, and y particular is 1 over this polynomial operator operating on 12e to the x. And we can, using this theorem, and it is a theorem, this says that I can recopy the 12e to the x and put it over this polynomial, replacing d with letter a. In other words, with a constant. So it now ceases to be a differential operator. It just becomes a polynomial. And a is equal to 1, so I'll plug 1 in here. I've got 1 squared plus 3 times 1 plus 2, which is 6. And so my y particular would be, that reduces 2e to the x. And so, boy, that was fast, wasn't it? So this theorem here, I would hang on to it. It's a great one for doing real simple ones. And I dare say it might even be quicker than method of undetermined coefficients. Probably is. And just make sure I didn't make some kind of silly error here. What page was that anyway? 282? Yeah. Problem 11. Y particular is 2e to the x. Great. It worked as it should. So, all right. So let's go on to a little more elaborate problem.